actually predicts the stock market. Machine learning truly predicts the stock. Build a Python script to predict. Today I'm gonna explain exactly. Today I'm gonna explain 500. That's a variable. If it goes up or down, trains a random forest mod. It up. I have done an edge on the market. Let's get an edge on the market. Let's get let's first we need data. The data first we need data and P500 directly, this one, by calling the history functions and setting the period to max. We're grabbing every single data to pull historical data for the P by having every single day of trading data available since 1927. But to make our model work accurate, we only really care about recent market behaviors. So later in the script, I filtered down data from 1990s. Here, okay. But to make model work accurately, we really care about the recent trades and recent data. So for that, I have put a label. Um, but to make model more accurate, we only really care about recent market behaviors. So for that, I have put a filter for 1990s onwards. But to make our model more accurate, we really care about recent market behaviors. For that reason, I have put a filter in the data, so we only get data from 1990s. Here's the code. Next, a machine learning model needs a clear goal. So I created a new column called tomorrow, which is just shift. Next, a machine learning model needs a clear goal. So I created a new column called tomorrow, which just shift the closing period to which just shift the closing period back to 1 day. Then, then I set up our target if tomorrow's pricing is greater than today's pricing. The the target is 1. If it goes down, the target is 0. The target is 1 if it goes down. The target is 1 if it goes down. The target is 0. The target is 1. But if it goes down, the target is 0. This turns our project into classic classification. Target is 1. If it goes, the target is 1. If is the target is 1. If it goes down, the target is 0. This turns our project into classic. The target is 1. If it goes down, the target is 0. Now, this turns our project into a classic classification problem. And for the brains of this project, I went with random forest classifier. For the brain of this project, I went For the brain of this project, I went with random forest classifier from scikit-learn. It's essentially a collection of decision. It's SESS essentially. It's essentially a collection of decision tree that vote on the outcome. It's essentially a collection of decision tree that votes on the outcome, which helps prevent model from just memorizing the data. And it's essentially a collection of decision tree that votes on the outcome, which prevent the model from just memorizing. It essentially a collection of decision tree that votes on the outcome, which helps prevents the model to just learning or it's essentially a collection of decision tree that votes on the outcome. It's help prevent model from just memorizing the data or overfitting. I set it to use 100 individual decision tree and require at least 100 sample before splitting into nodes. We need it. um, we feed it our prediction close volume. We feed it our predictors. We feed it our predictors close volume open high low and train it on all the data except the last 10 days. 100. We feed it we feed it our predictors closed volume high low. We feed it our predictors. Predictor. We feed it our predictors close volume open high low and train it on all the data except the last 100 data days. We feed it our predictors closed volume open high low and train it on all the data except the last 100 days, which keep hitting the test our module, which keep hitting to test our model later. We feed it our predictors closed volume open high low and train all the data except the last 100 days. We keep that data hidden from the day. We feed it our we feed it our predictors closed volume open high low and feed all the data except the last 100 days, and we will keep the uh, we feed it our predictors closed volume open high low and feed all the data except the last 100 days. We will keep those data hidden from this model so we can train them later on those 100 days. Now, if we just test this now, if we just test this normally, we might get unrealistic results. To make it act like a real world trading scenarios, I wrote a custom backtesting function. Now, if we just train this model normally, we might get unrealistic results. To make it act like a real world trading scenarios, I wrote a custom back testing function. This script takes 250 days of historical data, about 10 years of trading, to train the model and predict the exact next 250 days. It's looped through the entire datasets like this, sliding forward years by years. The result, a precious score of the result, a precise score of around 56. The result, a precise score around 53%. Now, that might not sound massive, but in the stock market, having the result, a the result, a precision score of around 53%. Now, that might not sound massive, but in the stock market, having a rental edge is better than just flipping coins and testing which is high, which is low. Finally, I code it to take the Finally, I code it to take the latest market data, split it into a live prediction. It doesn't just tell us up or down, it gives us the exact mathematical probability of model calculations. And to avoid retraining model every single time I went to check the market, I use a job lib to save the model as a pickle file. And to avoid retraining model every single time I check the market, I use job lib to save the model. I avoid by and to avoid training the model every single time I want check the market, and to avoid retraining the model every single time I went to check the market. And to avoid retraining model every single time I check the market and use joblib to save model as a pickle file so I can upload it instantly wherever I want. Predicting predicting the market is impossible, but building this machine learning pipeline is massive step up forward in understanding how the quantitative algorithm actually works. Thank you.